Hello, I'm Richard Hooper and this is Sat TV Week. Now I'm pleased to be joined by Eran Shapiro of Spacecom. Eran, thank you for joining me today. Let us start with the successful launch of AMOS 17. Why is that so important to the company?
Well, we had our share of bitter experiences in the last few years with especially with AMOS 6. AMOS 6 was supposed to be launched in 2016. We had multiple big anchor customers on it, including a very prestigious contract we have signed with Facebook. And unfortunately, the satellite was destroyed on the launching pad, causing us to scramble for how to support both our existing customers and some of the new customers we were hoping to have on AMOS 6. And it also delayed the start of the program for AMOS 17. So it's a very important step for us to go back to, let's say, normal business behavior, let's call it like that, where we are planning a satellite, launching it successfully, starting to provide service, working with our existing customers and our new partners on how to deliver the type of good services that we are known for in Africa, Europe, Middle East, and so on. So this is, for us, back to normal business behavior. So it's good to be back. Let's call it like that.
Now, looking at the satellite, what's so special about it?
Yeah, AMOS 17 is really a special satellite. It's first of all, it's a fully digital satellite, and it's a tri-band satellite. When we launched the satellite, we were having this press event with Boeing, and Chris Johnson, the managing director for Boeing satellite business, has mentioned that this is the first commercial tri-band fully digital satellite. So this was a new thing for them as well. And we have implemented in our design for AMOS 17 some of the lessons learned from earlier satellites, including AMOS 6, but also other satellites. And for us as a, let's call it, small to medium satellite operator, just producing yet another satellite like any other satellite doesn't work. We have to be special in some way. Otherwise, we don't have a chance against the big kids in the block. So, beside being a tri-band fully digital satellite, the design of each payload is also a bit different from other satellites. First of all, our steerable HTS Ka beams have a very unique way of sharing spectrum and allocating power between the beams. It's very suitable for government application, but also for large commercial applications as well. And our C-band payload is a fully HTS, high throughput type of a payload with beams covering all of sub-Sahara. Also here we have flexibility in the way we allocate spectrum between the beams. And with that we were able to achieve a level of performance that was never achieved before in terms of C-band satellites. If you look at the current satellites covering Africa, most of them are traditional satellites, peak IRP level of, let's say, 45, 46, 47 dB watt, and so on. You've got another satellite that have like 5 beams over Africa, but in our case it has 12 HTS beam over sub-Sahara. Each major country is served by a single beam, making both the performance over that country extremely high, as well as the ability for any domestic-centric type of service, like MNOs, backhaul, government services, and so on. You can keep all the traffic local. So that helps them in terms of how they design the network, in terms of how cost-effective the network can be for them. And when you're talking about Africa rural communities where the digital divide is still very significant, we made a lot of analysis prior to designing the satellite what operators and governments are looking for in terms to be able to have a cost-effective solution that is justifiable in those rural, low-density population type of areas. And the key point for them was, first, how can we minimize the initial cost, the capex, in terms of the equipment needed at those remote sites? And second, how we can minimize the opex once the site is up and running, how the total cost of operating it could be as low as possible. So first, with the total cost of the initial investment, we are not forcing our customers of existing telecom operators, MNOs, and so on, to change the current C-band equipment they have. If you have already a C-band equipment available in the field, there's no need to upgrade it. There's no need to change it. You can still keep it and enjoy now much higher throughput and performance using the very high performance of those C-band HTS beams. So that's the first step. The second step is, okay, when you look at the OpEx, OpEx has two parts of it, the satellite cost and the rest. And when you're going to those rural areas, in 99% of the time, you're going to off-grid type of locations, so there's no power available. So the option until now was usually to use a generator and a batteries and a solar panel all together at those remote sites. What we have designed those C-band beams specifically is how to make sure that you can go solar only, meaning that there's no need now for initial cost of a generator, and there's no need on the OpEx side to have someone come once a week, twice a month with a tanker to refill the fuel or the diesel at those remote locations. And especially in Africa, as you know, reaching those locations is extremely hard. It costs a lot. So if you can take that aside, you are reducing the total OpEx investment significantly. So in addition to the high throughput that we can generate on those beams, we also have an extremely high GOT levels on those beams. What it allows us is that the amount of power required to uplink back from those BTSs or public Wi-Fi location back to the core network is extremely low in power. Other satellite may need a buck of 10 watts. We need 1 watt. It's a big difference. Couple that with the advancement made in low power type of BTS systems, suddenly the initial cost and the ongoing cost for those rural locations going with a backhaul over satellite is suddenly making much more sense than it used to be. So for partners like MNOs and governments looking to work on that digital divide, that's extremely favorable for them.
Now, can let me pick you up on a point there? You talked about it's a digital satellite. Why is that significant?
Okay, a digital satellite actually allows us, in our case at least, limitless flexibility in how you architect your solution. And let me give you an example. In a traditional satellite, usually you uplink and downlink in the same band. Sometimes you can do a crossband between two beams in two different bands. But all of that is fixed, meaning that whatever is the rules or the functionality you are planning to have in your satellite, this is done ahead of time. And once the satellite is up in the sky, this is it. You may choose from 1, 2, or 3 configuration, and that's it. With a digital satellite, all those configuration, all those connectivities can be changed when the satellite is operating. As an example, let's say I'm currently a service provider, let's say Nigeria. And I have invested in a KU environment, and I have a hub in KU, I have terminals in KU, and I say that I have good business, but in order for me to also provide service in C-band, now I need to invest in a C-band hub and C-band equipment. What satellite allows you is actually to say, okay, you've got this hub in KU, we can use this hub in KU to provide service in KU in Nigeria, but the same hub in KU can also now provide service to other customers that may have already C-band equipment. So they don't need to change their equipment in order to be served by you, or you don't need to invest in upgrading their equipment to C-band. They can stay in C-band, they can keep their KU hub, and now expand their services to new type of market segment, new type of customers that were not available for them until now. The flexibility of the satellite, in which basically you have a non-blocking matrix between all the beams in all the bands, this is what it actually allows you. It's also provide you a very different approach on how HTS services can be provided. In typical HTS environment, you have, let's say, 20 user beams and 3 gateway beams, and the association of a gateway beam and a user beam is fixed, meaning if I'm in Nigeria in beam number 1, I may be served by a gateway in the UK, and beam number 2 in Nigeria may be served by a gateway in Germany. In our case, we are not forcing that type of one-to-one relation, which is fixed. Without digital platform, I can have a customer in Nigeria using a local hub. I can have a hub in the UK providing service to other customers within the same Nigeria beam. And I may have a third customer in South Africa also providing service into Nigeria, into the same service beam using a different hub. So all those hubs can operate simultaneously from different beams into that same service beam, that same user beam, something that other HTS systems cannot provide. So this level of flexibility doesn't force a partner to say, you know what, in order to commercialize a beam, I have to invest like $3 million in a hub, RF, everything in order to serve this beam or multiple beams. I cannot just use a normal, typical hub equipment like everyone has, and I still enjoy the HTS type of benefits. This is very exciting.
So, successful launch of AMOS 17. When's the next one?
Okay, so basically we're working on multiple opportunities here. I think everybody is following the news, the progress of AMOS 8. We are currently in still negotiations and discussions with our potential partner and our potential manufacturer. Things are not closed yet, but this will be the first, let's call it immediate suspect of what the next satellite is going to look like. On top of that, we are looking now also on some new space opportunity. Cooperation with some of the new constellation operators is one thing we are looking at. We are also looking between the two direction of geo satellites like VHTS on one hand versus small sats on the other hand. And in the middle you may have the flexible satellites like Boeing's or Airbus or Thales. We don't see ourselves going on a solo satellite in the VHTS realm. If we're going to do a solo satellite, most likely it's going to be a small sat or a flex sat. However, we do have some, at least a couple of opportunities we are currently looking at for a partnership with another satellite operator in one hand and a service provider on the ground on the other end to do a partnership where each party brings some components to the overall, let's call it joint venture or partnership in order to make it more cost effective for everyone. And I think we are not the only mid-sized type of satellite operator looking in this direction. With the LEO constellation on one hand and the VHTS satellite on the other hand, you must be cost effective or very special in terms of what you bring to the market. Otherwise, it's not going to be easy to compete in the next 5 to 10 years.
Well, exciting times. Thank you for talking to me.
Sure, exciting, and thank you for being here.